Good afternoon. My name is Patrick Hanratty. I'm with MCS Inc. And in the industry, I am typically called the caveman CAD person. Today, I want to present you a little bit of the history of what's known as precision in computing, and eventually evolving into where I think we belong today and where we're going to go tomorrow. When I first started in the computer world, I was using the Univac Scientific 1103A, which had no precision. It was a bunch of vacuum tubes and a very, very small word, evolving up to the IBM G650, which again was a biquinary machine with nothing that was appreciable in the way of precision. That evolved into machines that finally got to the point where there were some measurements that you could make and guarantee that you're going to get results. The IBM 704 had a software floating point that had a sign bit and 8 characteristic bits and 27 mantissa bits. So we could actually go in and do floating point. Now, all of these things evolved into a potpourri of computers that were just everywhere. There were so many computer manufacturers in the early 70s. Xerox, Redcore, PerkinElmer, Data General, VAX. The reason I have these machines here is because all except the very first two are ones in which I've installed created and installed either a CAM system or a CAD system. And so I thought, well, I'll show you what these things are. Today, in the world of precision, IBM has made a definition of it. They said that single precision is 32 bits. Double precision is 64 bits. And quadruple precision is 128 bits, 16 bytes, and it really is a fantastic thing for the future. This new precision, for over 5 years now, Intel has defined in its compiler the ability to handle quadruple precision, floating point. What this means to the CAD industry is that the CAD standard for precision has now jumped from 17.2 significant figures to over 33 significant figures. What does this mean? For one thing, solid modelers are no longer going to be limited to an actual part size of a meter cubed. Modeling will have no accuracy bounds that are really precision restrictions. For instance, you could take and generate the blending solid between the wing root of an aircraft and the fuselage of the aircraft, and then put a blend through that entire process in one single operation created at full scale. Who cares? After having talked to people last year at COFES about quadruple precision, at least the vendors in the industry, I found out that their customers didn't care. They didn't ask them about anything. And they didn't care. Yet. In 1986, MCS won the Sandia National Laboratory RFQ over every CAD/CAM vendor with Anvil 5000 and OmniSolids. The OmniSolids solid modeler was unbeatable. Whoops. What happened to unbeatable? Well, in 1988, Parametric Technology Corporation launched ProEngineer, a parametric solids modeler. With great marketing and parametric solids, PTC made the design world believe it could not exist without parametric modeling. In 1995, MCS quietly put its non-parametric OmniSolids to sleep. And we teamed with SolidWorks so we'd have a parametric solids modeler. This is a new lesson learned about technology. Quadruple precision is the parametric solids of the 21st century. Believe it. This will happen again, maybe to you who are the purveyors of modelers. Good luck.